Assalamu alaikum everybody. I hope that you are in good health and prosperity. In this brief presentation, we are going to talk about platelets aggregation and their mechanisms and their antagonists.
In order to understand the mechanisms by which antiplatelets will prevent aggregation of platelets. So how this happens, if we just imagine this is the platelet. Platelet contains different receptors. First are the protease activator receptors, protease activator receptor type 1, and this protease activated receptor type 1, there are receptors selected for thrombin, and thrombin, we have said before, it is produced by the coagulation factor 10A. Okay, this is the first receptor. The platelet also contains another purinergic receptors known as B2Y12 purinergic receptors. Okay, these purinergic receptors, they are receptors selected for adenosine diphosphate. So adenosine diphosphate will bind to these purinergic receptors. Okay, the platelet as well, it contains specific thromboxane A2 receptor. Thromboxane A2, as we know, is the product of prostaglandin metabolism, and it is pro-aggregatory and vasoconstrictor, as we will see inshallah later when we talk about local hormones or local autocoids. Okay, so also the platelets contains another type of receptors that are known as glycoprotein receptors type 2B and type 3A. Okay, glycoprotein type 2B and type 3A. These type of receptors, usually when the platelet is not activated, they are inert. They are not a site of binding to anything. Okay, now they are inactive. These receptors, they are inactive. Okay, once thromboxane A2 or thrombin or adenosine diphosphate, of course thromboxane A2 is produced by the platelet. Thrombin, as we have said, produced by the factor 10A through the conversion of prothrombin to thrombin, and adenosine diphosphate is produced by the endothelial cells, the injured endothelial cells, adenosine diphosphate. Once adenosine diphosphate or thromboxane A2 or thrombin binds to their receptors, in this case the glycoprotein receptors will be activated. They become active. They become active to receive binding with fibrinogen. Okay, so as we can see now, once this agonist binds to the receptor, the glycoprotein receptors binding site will be released, and this glycoprotein will be available for binding with fibrinogen. This is a fibrinogen molecule. Okay, so in this case fibrinogen will bind with the glycoprotein receptors. Okay, so very beginning receptors, the platelet is inactive. When it is inactive, the glycoprotein receptors, they are inactive. They cannot bind to any fibrinogen. But once different agonists binds to their receptors, they change the configuration of these glycoprotein receptors. They become available to binding with fibrinogen. Once fibrinogen binds to this platelet, it can cross-bridge with other platelets. As you can see, we started with one platelet, binded with 4 different molecules of fibrinogen. Each molecule of fibrinogen can bind with another platelet, with another glycoprotein receptors of another platelet. This will result in platelet aggregation. This will result in platelet aggregation. As you can see now, we started with an inert platelet, and an inert platelet where there is no platelet aggregation floating freely in the plasma. Once this agonist binds to the receptor, when they are released for any reason, they will change the configuration of the glycoprotein receptor, which becomes available for fibrinogen molecule, fibrinogen which is normally floating in the plasma as well. Fibrinogen will bind to these glycoprotein receptors, and this fibrinogen can bind to several platelets and therefore producing platelet aggregation. Okay, so as we have said, platelets first they are activated and then they are aggregated. Aggregation, of course, will result in formation of the platelet thrombus. Okay, now, so how we can prevent platelet aggregation? We can do that by either antagonizing. So we can antagonize thromboxane effect through the use of aspirin. Aspirin is well-known COX-1 inhibitor. Aspirin inhibits cyclooxygenase 1. This cyclooxygenase 1 is responsible for the synthesis of thromboxane A2. Therefore, by inhibiting COX-1, which is cyclooxygenase 1 will be inhibited, thromboxane synthesis will not be there, and therefore no activation of the thromboxane A2 receptor. So this is the first antiplatelet aggregation drugs, aspirin-like drugs. The second group, there are drugs which block adenosine diphosphate receptors, and these include the clopidogrel, most famous, clopidogrel, and ticlopidine. These both, they are antagonists. They block adenosine diphosphate receptor. Voraxabar, this blocks thrombin receptor. Therefore, they are antagonists at the thrombin receptors. Okay? The fourth group, they act by blocking the glycoprotein binding sites, glycoprotein 2B and 3A receptor. They block glycoprotein 2B and 3A receptors. Abciximab and tyrofeban. These are glycoprotein 2B and 3A inhibitor. Okay, so anticoagulants, they act by different mechanism, either by blocking synthesis of thromboxane A2, like aspirin-like drugs, or blocking the ADP receptors, like clopidogrel, or blocking thrombin receptors, and most famous example, vorapaxar, or by blocking the glycoprotein binding site. If you like my presentation, don't forget to press like. Please subscribe to my channel. Don't forget to share with friends. Wish you all the best luck. Wassalamu alaikum wa rahmatullahi wa barakatuh.